I'm having a really hard time with UPSs this month apparently. The UPS here is a UPS that I use for the entertainment center. It powers the flat screen TV, the stereo receiver, and the cassette deck, CD, and 8-track player. This is a APC Smart-UPS UPS 700 that I got from work that they said was bad. And so I just put new batteries in it not too long ago, and it's been a pretty good UPS. But about a year ago, I came home from work and smelled something really kind of sour in the air, kind of sulfury. And it turned out to, and I heard a hissing sound, and it turned out to be the batteries inside here gassing excessively due to what I thought was overcharging. And plus the UPS itself, the entire case was just extremely hot. So, took out the batteries and figured that they, maybe I got a bad pair of batteries, I'll go ahead and buy new batteries. And I did about a year ago, and I got these batteries, which are actually an upgrade from what APC called for. These are the high rate series batteries from PowerSonic that are specifically made for UPSs, and they have a higher amp hour rating than standard. I think the standard was 7 amp hours or 6.5 amp hours. These are much beefier. Well, a couple of days ago I was walking by the entertainment center and I noticed kind of a smell in the vicinity, that kind of smell that you see or hear, that you have with electronics getting hot, like circuit boards getting hot. It's kind of a unique smell. I'm not really sure how to describe it. It's not a burning smell. It's just a smell of stress, I guess, electronic stress. And the UPS was extremely hot again. And I figured, well, let me go ahead and get this thing apart. Maybe I've got the same problem going on. And sure enough, I do. If you look at these batteries really closely, you can kind of see in the light like a wavy top on here, and you can see the top starting to pop off, and I'm not sure if you can tell, you can kind of see the side of the case is wavy, and you can see some of the imprint from the other battery label on that side, because these batteries went into the UPS like this, and they're wired in series for 24 volt like that, and the whole battery pack goes into the UPS. And so when I took these batteries out initially, these batteries were stuck together, and I couldn't remember at the time. A lot of times the OEM will put double-sided tape between batteries to make themselves a module, and I couldn't remember if I actually did that or not, but they actually were pretty much stuck together. And this battery's got the same problem. So I think I got to these batteries just in the nick of time, and before they started gassing excessively and potentially cause a fire. And here's the date code on there. I'm not really sure exactly how to decipher that. 0609. Maybe September 2006 or maybe June 2009, probably June 2009, and so these are 3 years old. But I know these kinds of batteries don't last very long. That's one of the reasons why. But I never really had consistent failures of the batteries where they get into a condition known as thermal runaway, where they might develop an internal short. They start drawing more current from the charger, they start generating more heat. As they get hotter, they draw more and more current and get even hotter, and it's just an endless cycle until the weakest link breaks, which is usually the battery. So this is now the second time I've had this problem, and I'm beginning to wonder if I should be suspecting the design of the UPS. Now the UPS in the entertainment center, it's kind of in a tight space, I have to admit that. But also looking inside the UPS as far as design goes, there's just absolutely no ventilation in here. You've got a little bit right here on the side that's really kind of part of the inverter section. but I had this thing apart earlier, well actually last year, and there's no forced air cooling in here. There's no box fan or anything like that. This is not one of the heavier duty UPSs. So the batteries, if they do start generating heat, and all batteries do generate heat when you run a current through them for charging, there's really nowhere for that heat to go. But so there may be a design flaw in here as far as cooling, but I think what I'll do is give this one more shot. 3 strikes you're out, basically. I'm going to put different batteries in here from another UPS that I have and relocate this UPS into a more open area and see if I can get more life out of it, because I think I should be getting more than 3 years out of UPS batteries. Especially, I really shouldn't be getting failures of this type. I could see batteries going bad, but not to the point where they're getting hot and experiencing thermal runaway. You can tell how hot these guys were getting. If you look at the terminals closely, they're starting to have a little discoloration, a little bluish color. These batteries were extremely hot. When I took them out of the UPS, it took about 24 hours for them to cool down. And I think what ended up going on, we'll zero out the ohm meter here, is they started developing internal shorts, because as I was monitoring the voltage over a period of days, it started slowly decreasing. So this battery is running 6 volts, which is just totally gone. Definitely an internal short there. And this battery, 3.7 volts. So there's definitely an internal short in both of these batteries, draining that voltage right on down, just as if you had a load on here. So that's pretty disappointing, but that's actually not uncommon for batteries, especially car batteries, to develop internal shorts. I'm a little disappointed in the UPS from the standpoint that under these conditions there does not appear to be any built-in protection mechanism. The charging circuit in this UPS does not appear to be thermally regulated, nor does it appear to be current regulated. It's just a constant float voltage that charges the batteries all the time. Constant, 25 volts, no matter what, under any circumstance, it's always 25 volts. So if that battery starts developing a short, the charging circuit's going to try to ram 25 volts through there continuously and heat them up to the point where you have these kinds of problems where the battery basically is destroyed. So I've got to fault the design of this for that reason. If you know anything about the charging systems in cars, they are thermally regulated. When you start your car in the morning, especially on a cold morning, you might have an alternator voltage of around maybe as high as 14.8 or 15 volts. But after you finish driving and the engine's warmed up, that voltage might be down to 14.2 or 13.8. And they do that on purpose because batteries are temperature sensitive. As the ambient temperature changes for the battery, the charging characteristics change. And so that has to be compensated for with any kind of charging circuit. But, it's a Smart-UP 700. It's not the most expensive UPS in the world, so maybe that's one of the features that they delete in the lower end models. Or it could be that the UPS actually is defective, and that's why the people at work got rid of it. Maybe it is thermally regulated and that part of the circuit just isn't functioning. But I'll know that once I get the different batteries inside and give it another try and see how long it'll last. So the other UPS that I have is equally disappointing, unfortunately. This is a UPS I got back in maybe 1995, 97, and I spent real good money on this UPS. This is back when I was building computers myself and built myself my own computer. I got a Tyan Tomcat dual Pentium motherboard and Seagate Cheetah fast wide SCSI drives. I went all out on that computer, and this is the UPS I bought for it to kind of finish it off. And I chose this UPS because of its large capacity, and also because it had a true sine wave output, and you can actually start the UPS on battery. And then in addition to that, the batteries are hot swappable. You just unscrew these 2 screws, and you've got 4 batteries in here just like the ones over there, that you slide this whole thing out and you can replace them with the UPS running. But the reason I can't use this UPS to power the entertainment center is it seems to have failed for some reason. The computer I talked about with the SCSI hard drives and the dual Pentium motherboard is very old. It's basically the Pentium MMX processor, socket 7, which is extremely old. Can't really do much with it anymore but be a file server. It's running Windows NT 4. It can't run anything else. And I haven't used the computer all that much, and so this UPS basically has just been sitting around either powered off or just in standby with float charge on the battery. Well, come to find out, when I turn it on, it's got major problems, and I'll show you now. It's not plugged in or anything, which means we're going to start this thing up on the inverter. And you can hear that ugly noise it's making. Sounds horribly unbalanced. Sometimes you can smooth that out with a load. So I've got this 500 watt shop light that I use to work on cars and everything. We'll plug that guy in and see if that gets any better. Even worse. And now it doesn't even want to run at all. Low battery. So, and these batteries have been charging for a couple of days now. Even if this problem were caused by low batteries, it should not be making that kind of noise. So I've got some kind of problem with the driver circuits that power the inverter in here, and I don't really have a lot of time to fix it right now. So what I'm going to do is take the batteries, or two batteries, out of here. This UPS runs on 48 volt. 7 amp hour, whereas that UPS being smaller is 24 volt. So I'm going to go ahead and flip this thing around, take two batteries out of here, and go ahead and put them in here. And I'll show you guys how that's done with this UPS. It's really a shame that UPS is acting like that. This thing is really heavy. It's got 4 of those batteries in it. And I've replaced the batteries in that UPS before, and I went with as high quality as I could. I got the Uwasha batteries, which I believe might be made by Exide, but now they might be owned by some other company. And by the way, these batteries, as well as the ones over there, they're absorbed glass matte. Basically, it's the same technology that that's used for the battery I just put in the F250, the Intersys Odyssey battery, only on a much larger scale and designed for starting applications. But basically that's what this is. This whole module is totally hot swappable, field replaceable. And they really didn't want you breaking this thing apart and replacing batteries. Each one of these things was glued in there and really hard to get out. But they're basically just 4 12-volt batteries all wired in parallel. So I'm going to go ahead and disassemble this, probably take out these 2 batteries here and put them in the other UPS, and we'll see what we've got. Okay, now I've robbed Peter to pay Paul. I got those 2 batteries out of the other UPS, and that's what kind they are. A little bit lower capacity. Oh, they are Intersys, actually. I just noticed that. Cool. So this is made by the same company that made the battery for the F250, so these ought to be really good. The only other problem I noticed is that they seem to have a different terminal size versus the other one. This is the actual correct terminal size. So this doesn't really fit on there terribly well, but and it might create a little bit of heat from the loose connection, but I think I'll be okay, especially for purposes of testing. But basically we now have a 24 volt source, and now I'll go ahead and stick those in the UPS and see if we can get any luck out of this. So they just kind of slide in. The ones from the factory are actually glued together, so they go in a little bit easier. Doesn't matter which connector you put on there first. So a little bit of a spark there, probably charging up a capacitor or something. We'll just put them back in like that. And then you've got this cover plate that has these two tangs on the bottom of it that you line up in the bottom of the UPS. And then you just have these two screws that go in there. This part of it mechanically is actually a pretty good design. I don't know if these batteries are hot swappable. I tend to think that they're not, just because of the complexity to get them out compared to the other UPS. And now we'll go ahead and put the faceplate back on. Just being careful not to damage that ribbon cable. That always happens on these UPSs. Alright. Now we will test this thing out. I had a little bit of a beep, but that's normal. I could use that toaster back there with a toaster oven, but that would probably blow the UPS sky high. It doesn't like the battery charge state. It just initiated the inverter. It's in its test phase. Now the inverter just shut off. And now we're on utility power. So let me get the good old shop light. This is probably not going to work. It's 500 watts and batteries are just, for some odd reason, not charged up like they should be. So we do have light, and that's almost maxing out that UPS. Let's go ahead and yank the power and see what happens. Yeah, batteries are completely shot. This may not be a very good experiment, unfortunately. Makes me wonder if the charging circuit in that UPS is somehow defective. More than likely, though, the batteries are just not good anymore, which sucks because I don't want to spend a lot of money on new batteries for this UPS if the UPS is bad. So we got low battery, and it should go to the test phase in just a few seconds. There's the inverter. And low battery alert. And the inverter just shut off. Well, what I can do is I can go ahead and leave it like this. I can let this thing charge up for a couple hours, and just to see if this thing will charge up the batteries a little bit better than this UPS. And if it does, great. If not, I've got 2 more batteries in here I can give a try. Kind of like a flashlight. A lot of times in a flashlight, one D cell is bad, the other one's good. I'll just mix and match until I find a good combination. But I measure the open circuit voltage on the new batteries before I put them in, or actually the intersys batteries, and got 12.6 volts. Doesn't mean much. I mean, it's just open circuit, but they measured out okay. But we'll let this guy charge up all the way and test the inverter. I mean, I know the UPS itself works, and a 500 watt light almost as powerful as the inverter is. That's really a stressful test for it, but we'll see how this goes. I just wanted to share with you guys some of the UPS madness I've been having, and if you've got UPSs like this, or basically any kind of UPS, and it doesn't seem to be working right, or it starts beeping, these things self-test every day, or at least the good ones do, and if they fail to self-test, they'll either shut off, or have a warning light on, or they'll start beeping. Don't throw the UPS away. More than likely, it's just bad batteries. Just like a car battery, the battery goes bad over a period of time. They can only, last for so long. So try different batteries first. If you've got a small UPS and it just runs on a single 12-volt battery, or maybe a large 12-volt battery, hook it up to your car battery and see if the UPS starts working properly before you spend any money on it. But 9 times out of 10, there's not much to go wrong with the UPS. They're, by design, pretty beefy, hardy machines. You got to think that they do take a lot of abuse coming from the power line. They're designed to take voltage surges, brownouts, dirty power, all kinds of stuff. So it's pretty hard to damage these, except like a direct hit by lightning or overheating or mechanical damage or something like that. So 9 times out of 10, you guys can save yourself a ton of money by keeping the old UPS around and just changing your battery. I guess in this case, just make sure you keep your batteries cool.